In this video, we're going to use a Taylor polynomial of order 4 in order to estimate the value of 2 over e to the 0.1. If we're going to find a Taylor polynomial, then we need two things. The first thing we need is the function that we're going to estimate. So the function that we're using the Taylor polynomial to approximate. And the second thing that we need is the point A around which we're going to do our approximation. Remember that we can approximate any old function around a particular value of x, which we're going to call a, with a polynomial, which we get by taking the value of the function at the point a plus, and then we add on a bunch of terms. So this is the first order term, so we look at the first derivative evaluated at a, and we divide that by 1 factorial, which is just 1. Then we add on second order terms, so the second derivative, and that gives us our x squared term. That gets divided by 2 factorial, and we keep going as far as we want to. In this case, we want an order 4 polynomial, so we want to go as far as the term x to the 4, which is going to require the fourth derivative and give us an x to the power 4 term. And we divide through by 4 factorial. So in our particular example, we want to estimate a value of 2 over e to the 0.1. I'm going to write that as 2e to the minus 0.1 because I find that a little easier to work with. And if we have a look at that, we see that that really is coming from the function f of x equals 2e to the minus x, and we're looking at the particular case of x equals 0.1. So the function that we're going to be working with, that we're going to find our Taylor approximation for, is this guy. And the next thing that we want is the point A around which we're going to find our approximation. And for this, it's generally a good idea to pick an easy A close to the value you want to estimate. So if we have a look, we're wanting to evaluate when x is 0.1, so let's pick a is equal to 0, because that's going to be a very easy value to work with. So now we know the function that we're going to work with, and we know what our a is, so we can go straight ahead and find the Taylor polynomial. So we have f of x is 2e to the minus x. We need the first derivative. It's going to give us a minus 2e to the minus x. Second derivative, 2e to the minus x again. Third derivative is going to be negative 2e to the minus x. And finally, our fourth derivative gives us a 2e to the minus x. So now we have our derivatives, and we know that for a Taylor polynomial, we need to evaluate those at, so we evaluate at x equals a, and in our case we've picked a as 0, so we're looking at f at 0, and we know that e to the 0 is 1, so that's going to give us a 2. First derivative evaluated will give us a minus 2. Second derivative evaluated gives us a 2. Third derivative gives us a minus 2 again, and finally our fourth derivative gives us a 2. So now we have all our coefficient values, and we can plug straight in to find our Taylor polynomial. So here's our Taylor polynomial. We have 2e to the minus x is approximately equal to, so now we need our f at a, which is 2. And then we have our second term, so we've got our first order term, which is minus 2x, because our x minus a is giving us just x. Then we have 2 over 2 factorial x squared, and our third order term, which gives us a minus 2x cubed over 3 factorial, and finally our term with x to the power 4. And we have our Taylor polynomial. So what we've got here is a polynomial that we can use to estimate values of 2e to the minus x for values of x close to our a, which in this case was 0. So now we can use this approximation to find an approximation for 2e to the minus 0.1 by substituting x equals 0.1 into our Taylor polynomial. So what we get is that 2e to the minus 0.1 must be approximately equal to 2 minus 2 times 0.1 plus 2 over 2 factorial 0.1 squared minus 2 over 3 factorial times 0.1 cubed plus 2 over 4 factorial 0.1 to the power of 4. And if you plug that into your calculator, you'll see that that's equal to 1.8097. So what we've done in this question is we've gone a little bit further. We've worked out a fourth order Taylor polynomial around the point a equals 0, and we've used that to estimate our f of x value at x close to 0, in this case 0.1. I think it's a good idea to have an idea graphically of what we're doing. So I'm going to do something similar to what I did in the first question. So what I've got here is I've plotted the function 2e to the minus x. And what this question is actually asking us is to estimate the value of this function at the point x equals 0.1. So we want to try and estimate that value. So what we did was we found a Taylor polynomial that approximates that function, which I've got over here. And if I plot that in purple, you can see that we found a very good estimate for 2e to the minus 2x. So the final thing that we did was we said that the value of our function at 0.1 can be approximated by using the value of our polynomial, which we found at 0.1. And that was the value that we found over there. And as you can see from the picture, we're really going to get an excellent estimate for the value of our function at 0.1.